angle unchanged. It will keep the vector at the same location, or it will keep the complex number at the same location. So no matter what value you take for m, be it 0, 1, 2, 3, anything, every time you will see this result will be the same. It will be the same value. Here I have done something. I took n equals 0, n equals 1, n equals 2, 3, minus 1, minus 2, all the values I took in this same answer. In this same answer, just the value of n is 0, 1, 2, different values. And you see, you got the same answer every time. You got the same answer because there was a multiple of 2 and pi, multiple of 2 pi, multiple of 360 degree. So this type of a function is single valued. What if I change this square to cube or power 4 or power 5 or 6? Will it still be single valued or will it be multi-valued?
So single value.
It will still be single valued. Good. Because if you put 3 here, this 4m pi, it will become 6m pi. So still it's a multiple of 2 pi. If the power becomes 4, this angle will become 8n pi. Still that is a multiple of 2 pi. If the power is 5, this angle will be 10n pi. Still that is a multiple of 2 pi. So any integer you take in the power, it will remain a single valued function. On the other hand, I have shown some single valued functions here. Z to the power m, and the value of m is 2, 3, 4, 5, 114, 225, different values. And you will see all of them are single valued functions. So do this as a homework, but I think the concept is already clear. On the other hand, if I give m equals to 1 by 2, m equals to half, then z to the power half, that is the square root of z. So how many values will it have?
2.
It will have 2 values. We already learned from the chapter 1. We learned how to find the roots. So square roots, we saw there will be 2 roots. Cube roots, we saw there will be 3 roots. Or power 1 by 4, that will give you 4 roots. Power 1 by 5, that will give you 5 roots. So these are all multi-valued functions. Let's look at a different function. This function, g of z equals to ln z. Is this single valued or multi-valued? Okay, keep thinking whether this is single valued or multi-valued. Let us take one example, 1 plus root 3i, and convert it into the polar form. This is the polar form. y2 1 square plus root 3 square, then root. That is the modulus, right? So that becomes 2. And what is the argument? Theta becomes tan inverse root 3 by 1. So that is pi by 3 or 60 degree. That is the argument. So the polar form of the number is this. Now can we say, do you remember this? Log AB equals to log A plus log B. Is it right? So just do that here. ln of 2 multiplied by something. So it can be written as ln 2 plus ln the rest of it. ln e to the power I pi plus 3, pi by 3 plus 2n pi. Now this one, e to the power something, then ln. I think you also remember this. ln e to the power x equals to what? X, right? Okay. So this becomes ln 2 plus ln e to the power I something, or simply ln 2 plus I pi by 3 plus 2n pi. Now tell me, is this single valued or multi-valued?
Single value.
Okay, anyone else with a different answer? Okay, see, when I say, look at this. Say, for example, take n equals 0. Then this becomes 0, I pi by 3. I pi by 3 means, if you take calculator, the value of pi is 3.14159 something. Put that value, and then you will get something like this, 1.047. Take n equals 1, it will become 7 pi by 3, 7.33. Take n equals 2, it will become 13.614. So this, are they the same value or different? Does it look like the same value?
No, sir.
No, it is not. It is not the same. See, when we use this 2n pi, say for example, pi by 3 plus 2 pi. So their position is the same. Pi by 3 and pi by 3 plus 2 pi. They are at the same location, but their value are not the same. Pi by 3 is something, pi by 3 plus 2 pi is something else, pi by 3 plus 4 pi is something else. So it will change values. If there is some sine or cos, say here is a sine, then no matter what value you take for n, it will be the same. Sine of pi by 3, sine of pi by 3 plus 2 pi, sine of pi by 3 plus 4 pi, sine of pi by 3 plus 6 pi, everything will be the same. Be it sine or cos, any type of periodic functions. But this is not a periodic function. This is just a value. This is just a numerical value. Even if I plot this on the graph, Point 0.693 plus 1.047i. So it will be somewhere here. Then 0.693 plus 7.33. It will be here. So all the values will be like this. The real part is the same, but the imaginary part is different. It is getting bigger and bigger and bigger. Oh, or maybe even negative on the negative side, smaller and smaller. So these values as well. Do you understand the graph? Is the graph clear? I mean, conceptually, not scale wise, but conceptually. Is the graph clear?
Yes, sir.
Okay, good. So even if there is a multiple of 2 pi, there is no sine or cos or any periodic function. Okay, so this numerical value will change. See, this is for 0, this is for 1, this is for 2, -1, -2. If you take different values of n, you will get different results. So this type of function, logarithmic function, that is a multi-valued function. Did someone say something? Ananya Tasnim, yes.
গ্রাফটা আবার একটু বুঝা দেওয়া যাবে?
Yeah, sure. Let me. Yeah, let's think about this first point, Ananya. 0.693 plus 1.04 I. On the graph, how should it look like? Somewhere here on the first quadrant, this is 0.693 and this is 1.047 or whatever. Now, what about the second point, 0.693 plus 7.32? 0.693 at the same location, but on 7.33, that will be above here, right? If you take 13.6, that will be even higher, like this. Minus 5.236. So here. Now remember the complex graph. Okay. Any more question on this? Okay. So logarithmic function is a multi-valued function. Look at this problem. How can we solve it? Okay, so there is a big power, 100. If it was just 2 or square, it would be easy to use square formula, or for cube, we can use cube formula. But for higher powers, it's not easy to use those types of formula. Square formula, cube formula. Now, what can we do for such a big number, say 100? What can we do? Remember anything from our previous classes? Am I online? Am I connected?
Yes, sir. So we have to find the modulus and argument, and then
Okay, good. So yes, you have to convert this into a polar form. You have to find the modulus and argument. So 3 by 2 plus root 3 by 2 I. So which quadrant is it in? It's in the first quadrant, right? So we have the argument formula, just tan inverse y by x plus 2n pi. And we have the modulus formula, root over x square plus y square. So yeah, just complete the calculation and find the value of modulus and argument. So tan inverse 1 by root 3, it becomes pi by 6 plus 2n pi. This whole thing becomes root 3 e to the power I pi by 6 plus 2n pi. Now there is 100. Just put 100 on both sides. So put 100 on both sides, the power. So root 3 to the power 100, root 3 to the power 100. It will become 3 to the power 50, right? Because root means power half. So 100 by 2 becomes 50. So it becomes 3 to the power 50. And e to the power I, pi by 6 plus 2n pi, then power 100. So 100 will be multiplied by the power. So 100 pi by 6 plus 200 n pi. 50 pi by 3 plus 200 n pi. Now, in the question, there is something given. 3 to the power, this thing is given as 3 to the power 50, 2x plus 5iy. 2x plus 5iy. This one. This one was given. And on the right side, we got this one. So 3 to the power 50, 3 to the power 50 cancels each other. 2x plus 5iy, e to the power I something. So from Euler formula, you take cos theta plus I sine theta. Now you compare the both sides. Real part, imaginary part, real part, imaginary part. So this 2x will be equal to minus half, and this 5iy will be equal to this one. Yeah, then just find the values of x and y. X and y. Did you understand the problem?
স্যার এখানে 2x plus 5iy equals to minus half plus root 3 by 2i এটা কিভাবে হলো?
Okay. Can anyone answer this? Okay, who asked the question? Rida.
জি স্যার।
Okay, okay. Rida, you see cos something plus I sine something, and you have an n. What is the value of n? What should be the value of n? It can be 0, 1, 2, anything, minus 1, minus 2, any integer, any whole number. Yeah, just take any number and calculate it. Use your calculator, find the value. Cos
স্যার আমরা
55.
যে কোনো ভ্যালু নিতে পারবো।
Yes,
ওকে।
and every value will give you the same answer. You tell me why. Why will it give the same answer for every value of n? Because this is a multiple of 2 pi. this is 100 times 2 pi or 100n times 2 pi. So this is a multiple of 2 pi, multiple of 360 degree. And then you have cos and sine. So no matter what value of n you take, the result will always be the same. So cos 50 pi by 3. If you take the value 0, this value 0, you will get this one. Even if you take this 1, it will be the same. Even if you take this one 2, this one 2, this will be the same. If you take minus 5, this will be the same. Okay, any other question on this? Okay. Now there's the function z to the power half. You have to find h of z at z equal to this value. That means h of this value, 1 plus root 3i. So 1 plus root 3i to the power half. Because the question says h of z is z to the power half. So I think you all can do this. Can you?
Yes, sir.
Yes, just find the square roots. So do it as a homework. Here is the list of some examples of multivalued functions. So z to the power half, similarly 1 by 3, 1 by 4, or in general we can say z to the power 1 by n. That will be a multivalued function. For example, 1 by 6 or 1 by 7, any integer value. Argument is a multivalued function. Why? Why is argument a multivalued function?
Because we add 2 and pi.
Yes, because if you say n equals 0 and take this value, that is an argument. If you take n equals 1, then pi by 4 plus 2 pi, that is also the argument of the same number. If you take n equals 2, this will also be the argument of the same number. So the same number, for example, the same number 1 plus I, it can have hundreds of arguments. The same number, actually it has infinite arguments, infinite values of arguments. You just change the value of n, you will get a new value of the argument. So this is a multi-valued function. What about principal argument? Principal argument is a multi-valued function or single-valued function?
Single value.
Yes, very good. So if you take principal argument is the angle from the positive real axis. So from here until there, the smallest angle, or from here to there. So minus pi and theta pi. This is the range of principal argument. Minus pi less than principal argument less than or equal to pi. So this is a single valued function. Okay, and logarithmic function is a multivalued function. We already saw the example. Now there is a new term called branch. So let's take a logarithmic function. Say f of z equals to ln z. So we are converting this z into the polar form r e to the power I theta, or some value plus 2n pi. So it becomes ln r plus ln e to the power I argument. So in the end, it becomes ln r plus I theta plus 2n pi. So this is a multivalued function because you can change the value of n and you will get different answers. So this is a multivalued function. But for instance, say we are considering some specific range. For example, I'm saying in a specific condition or in a specific example, I'm saying that this theta can be only between 0 and 2 pi. No other value can be taken for this theta. It has to be between 0 and 2 pi. Then does it still remain a multivalued function or does it become a single valued function?
It becomes single valued function.
It becomes a single valued function because when you take n equals 1, it takes some value 2 pi plus theta. So that exceeds this limit. If you take n equals -1, -2, or +2, +3, any value, it will take the value outside this range. If you want to take it within this range, it has to be one single value. So for example, if I say 150 degree, 150 degree between 0 and 360 degree, that is the only value, 150 degree. If you take 150 plus 360, that is, it can also be written as 410, but that is not within this limit. So 410 degree is still the argument, or it can be still the answer of this ln z. But when I say it has to be within 0 and 360, then 410 cannot be taken. Then this is wrong. Then only 150 has to be taken. So it becomes a single valued function. So a multivalued function became a single valued function because we are considering a certain range. This certain range is called a branch. In this case, 0 to 2 pi, this range is a branch. Branch can be any range. We can take between -pi to pi, like principal argument, or we can take from -pi by 2 to 3 pi by 2. So it will depend what is said in the question. If I say the value has to be within this range, then it has to be within this range. You cannot take any other value. For example, let's look at this function. F of z is argument of z. Then what is f of 1? F of 1, that means argument of 1. So it can be 0 or 2 pi or 4 pi or -2 pi, -4 pi, anything, right? Because 1, where is 1 on the graph? 1 here. Oh, sorry. 1 is here. So what is the angle from the positive real axis? The angle is 0. So it can also be 0 plus 2 pi, 2 pi. or 4 pi or minus 2 pi or minus 4 pi, all the same thing. All of them are the argument of 1. But if I say that f of z is argument of z, but minus pi less than argument of z less than or equal to pi, then what will be the answer? Do you still have the same answers, all of them, or will it change? So 2 pi. 2 pi in general, yes, it is an argument of 1. But when I say this range, does 2 pi fall under this range? Does it fall within this range?
No,
No.
2
Sir.
pi? No, it doesn't.
sir.
So 2 pi cannot be taken. Similarly, 4 pi cannot be taken. Minus 2 pi cannot be taken. When I say between minus pi and pi, it has to be only 0. And no other value. Only 0 is right. See, if I say f of z is argument of z, where argument of z has to be between 0 and 2 pi, then f of 1 or argument of 1 has to be only 0. Similarly, f of I, argument of I, previously it was pi by 2, 5 pi by 2, 9 pi by 2, minus 3 pi by 2, minus 7 pi by 2, anything. But when I say it has to be within this range, it has to be only pi by 2. Similarly, if I say it has to be within this range, then what about f of 1? What about argument of 1? Did I write it correctly or is it wrong? Should it be 2 pi or should it be 0?
So 2 pi, because it says
Should
it
be 0.
0 is greater than not equal to 0.
Exactly. Just compare it with the previous example. Here 0 less than or equal. Here less than or equal with 2 pi. So argument of 1 was 0 in the first case, but 2 pi in the second case. Is the difference clear? Is the difference clear to everyone?
Yes,
Yes,
sir.
sir.
Okay, very good. Say if I say argument of minus I within this range. In general, argument of minus I we had here. Argument of minus I, it can be minus pi by 2, minus 5 pi by 2, minus 9 pi by 2, or even plus 3 pi by 2, plus 7 pi by 2, anything. But if I say argument of minus I within this range, then it has to be minus pi by 2 and no other value. And if I change the range, if I change the range to this, if the range is between 0 and 2 pi, then the argument of minus I will be 3 pi by 2. Yeah. Again, compare these two, 3 pi by 2 and minus pi by 2. If there is no range, then yes, both of them are the same angle. But if I mention any range, you have to carefully look at the range. If it is between minus pi and pi, the angle will be minus pi by 2. But if it is between 0 and 2 pi, it will be 3 pi by 2. Because minus pi by 2 is not within this range. Minus pi by 2 is not within this range. And 3 pi by 2 is not within this range. Now is it clear to everyone?
Yes, sir.
Okay, very good. So any question on branch? Okay, then let's move forward. Yeah, sometimes in the exam we see this type of a question. Show that ln of something equals to something. You see, on the left side it is a logarithmic function, and on the right side there is no log, or maybe it is looks a little different. So how to prove it? In case of logarithmic function, in most cases, it would be convenient to simply convert the complex number into polar form. For example, in this case, root I. So let's take I into the polar form, r e to the power I theta. Then what will be r? R will be 1. The modulus of I is 1. If you look at the graph, I is where? Here is I. So the distance is, this distance is 1. And the angle is pi by 2.
90.
Yes. So that's what I did here. The modulus is 1 and argument is pi by 2 plus 2 and pi. Then I becomes 1 e to the power I pi by 2 plus 2 and pi, or simply e to the power I pi by 2 plus 2 and pi. So now ln root I, that means ln I to the power half. This half can be brought in the front as the coefficient. So half ln I. Now the I, the value of I from here, e to the power I pi by 2 plus 2 and pi. ln e to the power something, that something goes in the front. ln e becomes 1. We got what we needed. Yeah. So this type of problems you have to practice. I'm just showing you the concept here. Later on, you will practice all of them as a homework. Yeah. Is the concept clear? Or is there any question on this?
No, sir.
Okay, very good. So similarly, do this as a homework. Let me show you something. Minus pi by 4 and plus 7 pi by 4, they are the same angle. Is this concept clear to everyone? Minus
Yes,
pi
sir.
by 4 and 7 pi by 4, or minus 45 degree and 315 degree. Do you have any question on this? If all of you are okay with this, then this problem should be very easy to solve. So do it as a homework.
Sir, we have to take the closest angle from real axis, right?
From the positive real axis, the closest angle for principal argument. But if I don't mention principal argument, then you are free to take anything. You can take the closest angle, or you can take the other value from the other side, or you can take one rotation complete, then again from the other side. You can take in different ways. Unless I have mentioned something specific. Something specific like principal argument. If I say principal argument, it has to be minus pi by 4 and nothing else. Now clear?
Yes, sir.
Okay, very good. Now, look at this. solve the equation e to the power z equals to -2. Okay, first of all, is it possible? Is it possible to have a negative value with some number in the power of e? So e to the power 1 equals 2.7 something. E to the power 2 equals 8 point something, or 8 point, or maybe less. But maybe, okay, find it out. E to the power 2, e to the power 3, e to the power 4. Is there any chance they will be negative, or all of them should be positive?
Any complex number, then what will happen?
Yes, exactly. So for real number, even if you take negative e to the power -1, yes, it will be less than 1, but still positive. E to the power -2, it will be less than 1, but still positive. But whenever you take some complex number, say 1 plus I, or ±1 plus minus I, take different combinations, then it is possible to have negative answers as well. So just by looking at the negative sign, don't think it is absurd. No, it is not absurd. It is possible. It is possible in the context of complex numbers. So how to solve this equation? E to the power z equals to -2.
We can take ln on both sides.
Exactly. Yeah, take it. Z will become ln -2. Now, ln of something, logarithmic function. Previously, we have seen whenever there is some logarithmic function involved, we try to take this number into its polar form. Then it becomes easy. So let's take it. Let's take the polar form of -2. What will be the modulus? Modulus is 2. And argument? -2 is here. So the distance is
180 degree.
Distance is 2 and the angle is 180 degree, or
180.
pi. Yeah. So modulus is 2 and argument is pi plus 2n pi. So -2 is 2 e to the power I pi plus 2n pi. Put this value here. So z becomes ln -2. Put the value of -2. So ln 2 plus ln e to the power I something. So I, this one. Then take pi common, then 1 plus 2n, 1 plus 2n. Yeah. So this is the answer. Because it said solve. Solve means find the value of the unknown. In this equation, z is unknown. We don't know for which values of z this equation will be satisfied. So we are trying to find that value, and this is the value of z that will satisfy the equation. So here I have given some examples, but it is not mandatory to write it in the exam. I have given some examples to make you understand. If you take the value of n equals to 0, 1, 2, -1, -2, different values will give you different answers. So it will have many different answers, multi-valued function. But we can keep this until this. This should be a good answer. Or sometimes it can also say that prove that ln -2 equals to this. It can also say that. Prove that ln -2 equals to this. So it's the same thing. Similarly, this one, e to the power z equals to some number. So in this case also, we can take z equals ln 1 plus root 3i, then convert it into polar form. Then the rest of it should be the same. Again, exp, that means e to the power something. It's also written in this notation. It means e to the power 2 plus minus 3 pi I. This one is actually easier. So you can keep it like this: e square times e to the power plus minus 3 pi I. Then this one has Euler formula: cos theta plus I sin theta. Cos 3 pi minus 1, sin 3 pi 0. Got it? Yeah. So similarly, try this as a homework. Yeah, it should be easy. So any question on this concept, converting into polar and find the logarithmic function?
No, sir.
Okay, then this page, if you remember from the last class, I said some of the pages can be skipped. So this is that part. So if you have time and interest, you can look into this, but no need for our syllabus. Okay, so algebraic functions, we saw. Logarithmic functions, we saw. Now, circular function. This one also, I think we started. We saw this in the last class. We have Euler formula. So we have e to the power minus I theta. That will be cos theta minus I sin theta. Then this one and this one, add them, you will find 2 cos theta. Or subtract them, you will get 2 I sin theta. So from there, we found cos theta and sin theta. So we have sin theta and cos theta. Can we get tan theta? We can get
Yes, sir.
tan theta.
Sine by cos.
Just sine by cos. We can have cot theta by 1 by tan or cos by sine. We can have sec theta 1 by cos theta. We can have cosec theta 1 by sine theta. Then if you look at the sine and cosine formula, this is cos, this is sine. Take cos theta as x, sine theta as y. X square plus y square. Do the calculation yourself. Cos square theta plus sine square theta. In the end, you will get 1. So x square plus y square equal to 1. It indicates a circle, right? Center at 0, 0 and radius 1. So it is a circle. That is why this type of functions are called circular functions. Then we also have hyperbolic functions. What is hyperbolic function? Remember the formula of cos theta here and sine theta from here. Now, if you take this I, this I, this I, this I, this I, if you take all the I's out, just remove the I's. So there is I theta minus I theta, I theta minus I theta, 2I. So I have removed all the I's. Then the new cos theta is called hyperbolic cos theta. The new sine theta is called hyperbolic sine theta. Because if you change the I theta into simply theta, There was I theta, but you are changing it to only theta. Then the function will not remain the same. It will definitely change. What will it become? It will become something new. This is the new function. We name it like this, just because it is similar to cos theta. Just if you give I and minus I, then it will become cos theta. And if you remove the I, it will become cos 8 theta. It is called hyperbolic cos theta. Similarly, we had I. Just remove the i's, the sine theta will become sine 8 theta. It is called hyperbolic sine theta. Did you understand this too?
Yes, sir.
Okay, very good. So now we have hyperbolic sine theta and hyperbolic cos theta. Can we have hyperbolic tan theta?
Yes, sir.
Just hyperbolic sine by
Yes.
hyperbolic cos. You will find the answer. If I say hyperbolic cot theta, just 1 by hyperbolic tan, or hyperbolic cos by hyperbolic sine. Or we can simply say sine h theta, cos h theta. We can simply say that. That h means hyperbolic. So similarly, sec h theta, cosec h theta, we can find all of them. Now, why are these called hyperbolic? Just look at this two. Take this one as x, this one as y. Then find x square minus y square. So cos h square theta minus sin h square theta. Put the value. Similar to the previous one, complete the calculation, you will find this x square minus y square equal to 1. This is the graph of a hyperbola. That is why this type of function is called hyperbolic function. So do the calculation yourself, but this is the concept. Okay, so in the exams, sometimes we can have hyperbolic sine or cos theta. You have to be careful. This is not the same as sine theta. There are some similarities, but it is not the same function. Sine theta and sine h theta are totally different. Similarly, cos theta and cos h theta are totally different. Clear? Any question on hyperbolic functions? Okay. We have another type of function called inverse circular function. What is circular function? Sine, cos, tan, these are circular functions. So what is inverse circular? So if sine theta equals to z, then theta is called sine inverse z. Sine inverse of something. This is the definition of inverse circular function. If z is the circular function of theta, then theta is the inverse circular function of z. Is the definition clear? If z is the circular function of theta, then theta is the inverse circular function of z. This is the inverse circular function. Sine inverse, cos inverse, tan inverse, all this. Now, sine inverse z. We don't know how to find its value. How to find its value? So the question says, find an expression for sine inverse z. Or it can also say, show that sine inverse z equal to something they can give. Show that sine inverse z equals to this. How can we solve that? Okay, so if sine inverse z is given in the question, for our simplicity, we are taking it equal to theta. Let sine inverse z equal to theta. Then from definition, z becomes sine theta. And the sine theta, definition of sine theta from Euler formula, you remember that? E to the power I theta was cos theta plus I sine theta.
I sine.
E to the power minus I theta equal to cos theta minus I sine theta. So e to the power I theta minus e to the power minus I theta, cos theta cancelled, we get 2I sine theta. So sine theta becomes, just send this 2I to the other side. E to the power I theta minus e to the power minus I theta by 2I. This is the definition of sine theta. Remember? Yeah, this will be required very often in the course. So you have to at least remember the basic formula, the Euler formula, or even better if you remember the definition of sine theta and cos theta. Like this one, sine theta equal to this. You can directly say this. So we need to find sine inverse z. That means we need to find theta. So in this equation, try to find theta. Keep the thetas on some side, keep everything on the other side. Send this 2i to this side. So 2iz. Now this can be solved in different ways. Here I have done something. Remember this formula? A plus b square equal to a minus b square plus 4ab. We saw it in one of our classes. We saw that. But we can also solve it in different ways. Anyway, let's stick to this one. So a plus b whole square equals a minus b whole square plus 4ab. A minus b value we know, 2iz, then square. And e to the 4ab, e to the power I theta, e to the power minus I theta. Cancelled. Just 4. 4. I square becomes minus 1. So the whole thing becomes 4 on minus z square. There's square. So e to the power I theta plus e to the power minus I theta. It will be 2 root on minus z square. Now look at this equation and this equation. Now solve it. If you add them, this one and this one, if you add them, this one cancelled, e to the power I theta, e to the power I theta, 2 e to the power I theta. On the right side, do the calculation. Then e to the power I theta, do the calculation. I theta, take ln on the other side. Or if you take ln on both sides, this one will be cancelled with e. So just I theta equals ln something, theta equals to the I on the other side. And 1 by I is also minus I. You remember that from the last class?
Yes, sir.
Yes, good. Those of you who remember, 1 by I can be written as I by I square. And I square is minus 1. So I by minus 1 or simply minus I. So now we found an expression for sine inverse z. See, this whole thing only has z. There is no theta. The z was in sine inverse z. It was in the question. So we are writing in a way that we know. We know how to find the logarithmic functions. We know how to multiply with I. We know how to do the addition or subtraction of complex numbers. We know how to find the roots. We know everything. So this is a format that we know. So sine inverse z, we have converted this into a familiar format. So this is for sine inverse z. Similarly, you do for cos inverse z, tan inverse z, cot inverse z. You do that yourself as a homework. Any questions on the last problem, the sine inverse z conversion or expression?
No, sir.
Okay, good. This part, it can also be solved differently. For example, you took this, so z becomes sine theta, then you put the definition of sine theta from Euler formula, then e to the power I theta minus e to the power minus I theta equals 2z. Okay, now what you can do, from here you can write e to the power I theta minus 1 by e to the power I theta equal to 2iz. So e to the power I theta square minus 1 equal to 2iz e to the power I theta. E to the power I theta square minus 2iz e to the power I theta minus 1 equal to 0. Now e to the power I theta, compare it with x. Then the equation is x square minus 2izx minus 1 equal to 0. So this is the quadratic equation of x. Can we solve that? Yeah, just use that formula and solve it. You will get the same answer. So whichever you find easy, you can follow that way. Okay. So any question on inverse circular function?
No, sir.
Okay, very good. So do the homeworks, especially the last portion, the inverse circular function. Do the homeworks, and if you have more time, do inverse hyperbolic function in the same way. But if you don't have much time, at least do the inverse circular part. Then inverse hyperbolic should be easy. So that will be your homework. Inverse circular function. Then in the next class, we will start limit. So in real number, we saw limit, continuity, differentiation. Now we will see that in the complex numbers. Limit, continuity, then differentiability, then differentiation of functions. So whatever we learned in real number calculus, we will also see that in complex number calculus. Complex differentiation, complex integration. So for now, stick to functions. In the next class, we will start limit and continuity. Okay. Any question on any topic from today's class? No question? Anyone? Okay, then you keep studying yourself, keep practicing, especially the homeworks that I gave. Practice the problems yourself, then the concept should be clearer. And then it will also be easier to focus on the next classes when we start limit and continuity and differentiation. Okay, so if you have no more question, I think we can wrap it up today. Yeah, looks like nobody has any question. So, okay, thank you everyone.